back for more documentation. Lesson 2 covers chapters 4, 5, and 6. Chapter 4 starts with variables, so there's a couple of the topics that are covered in that chapter. So we're learning how to declare and initialize variables, when to use them, different data types associated with variables as well, and understanding some system variables that are built into processing as well that are really handy and useful. And there's some 3 questions that come up in the chapter that are handy to ask when using variables as well. And the exercise that I wanted to document for lesson 2 was exercise 4-4, which is to recreate those 3 screenshots at the bottom of the video there, and to use hard-coded values, then variables, then make those variables change. So that is screenshot number 1, recreated with those hard-coded arguments going into the ellipse function. So yes, size and location are just hard-coded in. Step 2 is to take it up a notch and use variables instead of those hard-coded values. So for now, we're just initializing, we're declaring and initializing those variables at the top of the sketch and popping them into the ellipse function. And step 3 is to make those variables change in some way, make them vary in order to get some form of animation happening and things to change on the screen. So I don't know why that was what I decided to do, but that's what happened. Those circles are gone forever. They and the colors being decided randomly as well using the random function. So that was picture 1. Picture 2, so step 1 again is to just recreate that screenshot using hard-coded values. I don't know why I got an error there. Oh, it looks like I just forgot to comment in step 1. That is the recreation using those hard-coded values. Not much to it. Step 2 is to use the variables. And I was getting an error there because I forgot to change the names of the variables in the line arguments. So if we declare a variable, we have to match the name when we reference it. Otherwise, processing is not going to know what you're trying to say. So there is the recreation using those variables. And step 3 is to assign new values to those variables and make them change. So it looks like I did a bunch of random assignments there. I have like a weird funky YT thing with the random colors and size and thickness and position happening, but kind of cool and fun to look at. And picture 3, so exact same thing as the others, recreate that using hard-coded values in the arguments, then using the variables that have been declared and initialized at the top of the sketch outside of the draw and setup, and then to change the values of those variables. So that kind of looks like a little speaker or something. Maybe not a very creative use of the example, but that's what it is. So chapter 5 was all about conditional statements, Boolean expressions, conditional statements, if, else, relational and logical operators, and there were some extras in there as well. So using relational operators to create conditions for certain code to execute. Using the Boolean switch was also a really cool insight and quite handy to internalize and use moving forward. There were some like physics 101 examples as well. There was a state variable example that was really cool to see as well, to think of using a variable as kind of like a scene. An example, exercise 5-5 was the one I chose to do first, which is to create a rollover. So when the mouse is hovering over a shape, make something happen. In this case, it's a rectangle, and when the mouse is over the rectangle, it turns green. Otherwise, it is yellow. Using that if statement, the if and else statement there, to check to see where the mouse location is in relation to the y position, the y plus width, or the y plus height, and the x position and x plus width of that rectangle, using those relational operators and the if statement. And step 2 of that exercise was to try it with a circle, which is a little bit different because it doesn't have like edges. So instead of using the x, y, and then x plus width and y plus height, you just use the radius and the distance function, which is, I don't think that one has come up before, but using the distance function that is built into processing, that uses the Pythagorean theorem to calculate the distance between the mouse and any other point, then we can just see the distance of the mouse in relation to the center of the circle. And if that distance is greater than the radius of the circle, which is half of the diameter, then that means the mouse is within the circle, or outside of the circle rather. And when the distance is less than the radius of the circle, that means the mouse is inside, and that circle will turn green. And then the next exercise I did was exercise 5-6, which is another rollover, but with 4 rollovers, and using like different quadrants of the sketch, and also a variable to change the behavior of the rollover. So whenever the mouse is in a certain quadrant, the fill is set to 0, and then when the mouse moves away from that quadrant, 0, so the color of that quadrant is incremented by the amount of the fade variable, which is set to 10 there. So every loop, every time that the draw loop loops, a value of 10 is added to 0 until it reaches 255, which is white. I made fade as a variable so that I could change how quickly or slowly that fade will happen. So depending on how much the fade color increments by through each draw loop, and using that if and else if to create that rollover. Chapter 6 was all about loops and iteration, using loops to iterate certain code within a block. We went through the while loop, or Dan went through the while loop, the for loop, and the do while loop. Well, he didn't go through the do while loop, but just the for loop and the while loop. And it's sort of a key insight is that they happen within one iteration of the draw loop. Learned about scoping as well, and there was some operation shorthand that was quite handy to learn as well, to see as it comes up in a lot of examples for processing. And instead of using any examples from the text to look at the for loop, I looked at an example from the Coding Trains processing or coding for beginners, and we looked at 10print, which is a famous one-line Commodore program that generatively creates a sort of maze-like pattern, and there's a whole book available for free, or PDF, about 10print, written by a bunch of people, including Casey Reese, who's one of the co-creators of processing. And so I've just taken Dan's code from that video and recreated it for myself, or just copied to create that 10 print. And I think I'm using the no loop function there, so that's why it's not happening over and over, but that's an example of using a nested for loop to check every X and every Y location and create a diagonal line in a certain direction depending on a random function there. So if r is less than 0.5, then that line is drawn in one direction, otherwise it's drawn in the other, and it creates that funky maze-like pattern. And the lesson 2 project is to take your lesson 1 project and recreate it, but using those variables, using for loops, using conditional statements, everything learned in or covered in the lesson. Now we have an animated and slightly interactive funky Felix. The little grass and his little stems move according to the mouse location. Oh, I used the map function as well. I looked up on the reference, on the processing reference. There's a rollover as well that reveals Felix's little face. So using the rollovers that were covered in the text. And I have a mouse wheel event as well, which I don't fully understand yet, but I did look that up in the processing reference. And basically when the mouse wheel is scrolled, it sends a value that is using that get count method. I think that's what it's called. And that changes the rotation of the pedals. And I also used a for loop to create rain. So when the mouse is pressed, there is rain. Those are the new functions that were introduced in lesson 2, random, int, and constrain. So those are good to internalize, go through in the processing reference, and just use as much as possible. That is pretty much it. It was a fun lesson, and the next one is lesson 3. I'll be back for more documentation. Peace out. Goodbye. Oh yeah.